Thank you.
Mm-hmm.
Okay, everyone. So this week we are changing gears a bit, and I'm going to be talking about packaging your code or your data into an R package. And today the material is going to be an overview of packages, but also show you how to create one in RStudio. It's quite straightforward. And let's go here. So topics. So today is like an introduction, and I think this is good for everyone to learn about, even if you're not the person who's making the package. Understanding what they're able to do and how they can fit into your team workflow is really good information. And then also, when you do have a package, especially like a data package, you're going to have different team members working on aspects of that package, and I'll talk about that. And then on the week after that, I'm going to talk about how to create a web page using package down and how to apply a NOAA branding to that. That's another really good one, I think, for everyone to see, just to kind of open your mind, your ideas for what's possible and how this can improve your workflow in your team, make your team more efficient, and then obviously also create a kind of a landing page for the package. And then the last week is the one that I think will be mainly interested for people who are actually package developers, the ones who's like really putting together the structure. And I'm going to go through some of the things that really hang people up and, you know, you end up spending a lot of time on, and if you understand it, you will not spend all that time pulling out your hair. Okay, so that's the structure of these 3 weeks. And then, as always, you can go up to weekly notes on the webpage and find the notes, and then the lecture notes, and then I put the video here also. Okay. And then for logistics, as usual, throw your questions in the chat. And if somebody has an answer to that, please feel free to answer it. Just jump in there, help each other out. I will be tracking it also, but if the question gets answered first, that's perfect. Okay, so let me get that down and get that chat down here so I can see what I'm talking about. Okay, so why would you put your code and your data into a package versus just having like a repository that people could copy, or that you yourself could copy? Like, why, you know, let's say you're working alone. Why would you ever like put all your code into a package? It's a bit of extra work. First off, this adopting this framework is going to make your code much more robust. I know it's a little extra work, but you're going to be so much more organized, your code's so much better documented, so much easier to test your code and to write code that is compartment, so like modular code that you can use for other projects. It's not all like this, you know, custom code just for this one little task. It's really going to make you a better. It's just going to make your workflow more efficient and more robust. You'll be faster, much faster in the end in doing your work. And another really key feature is that it's going to allow you to version your code so that you can you know, like when you do an analysis or you write something, you can put like a line down, you know, archive and say, hey, this is the version that was used, and that's going to mean something. So that way you can replicate things you've done in the past, and it's going to make it really easy if you would like to see the version of your code in the past, or like work in a workspace of the past. So it's just like one little line of code, and on your local computer, you can issue a git command and go back in time to a status of your code in the past. So that's really useful. I think for me, the versioning is most useful just in that I always know what version of the code or the data somebody is using, and that we are using when, like, in reports and analyses. Okay. So that's all the great things about it. Oh, documentation. Oh, I'm going to cover that a lot more in week 2, but you're going to see some examples. And I think the documentation framework for packages is just the best thing. It's really, really helped me once I committed to the documentation framework within our packages. And that's not just for code, that's also for data. Okay, so let's get going. Let's make a package in RStudio. So if you want to follow along, there's potentially some setup. So if you're a Mac user, you don't have to do anything. If you use RStudio Cloud and you use the link that I shared, you don't have to do anything. Windows users, okay, so if you have the updated RStudio and updated R, you might not have to do anything. You should at least try to follow along and see if you run into problems. For many, many years, Windows users have had to install something called RTools, and you might still need to do that. I don't know the status right now, because right now I'm working mainly on a Mac. I do have my PC, but my PCs all have RTools, and it's already set up, so I haven't been able to just go onto a sort of a fresh, naive PC and test if these things work on them. So anyhow, try it without RTools. If it complains, then you're going to have to go here and install RTools. If you, just a note, if you're installing packages with C++, then there's some extra steps. I'm not going to cover that today. I may get into that on the third session. Okay, so let's just jump in there, and we're going to make a package. So I am going to RStudio. I am going to do a new window. Yeah, you can go up to the top. I'm going to say new project. Putting it in a new directory. Oh, goodness gracious, let me make sure I deleted this when I was testing it. Move to trash. Okay, because I'm going to be putting it there. Okay. Okay, take 2. Okay, so now I've gotten to new directory, and I click on, sorry, I did that kind of fast. I'm clicking right here, and then I click on our package, and I'm going to give it a name, and I'm just going to call it my new package. You can call it whatever you want. You don't need that. You need to look down here, see where you're creating it. I'm just going to put it on my desktop. Create a Git repository. Yeah, I'm going to go ahead and do that. I am going to be able to do that because RStudio knows where I have Git located. I'll show you that real quick to remind everyone how that works. So I'm going to do that, and I'm going to create that project. Okay. There we go. I now have a package. Voila. Okay. Just to remind you about that Git thing, it's right here, Tools, Project Options, and Git SVN. And so origin, I don't have this linked anywhere, but interesting. Why is that not? It's somewhere here. I don't know why I'm missing something here. No, don't do that. Okay. Anyhow, let me keep going. Okay. Cancel. Okay. So now I've created a package. And once I've created that package, I now have this build tab here. And I'm going to click install and restart. And it's going to install my package. There we go. So that's it. That is creating a package in RStudio. And it creates a template. It's got the basic things that you need for this package. So let's go through what the basic things are, and I'll show you them as we go through. Okay, great. Okay, for those of you who don't have RStudio on whatever computer that you're working on, you can also go to RStudio Cloud. So like if you want to follow on or you're on a phone or something, you can, or a tablet, you can just go here, click there, and follow along with RStudio Cloud. Okay, so there's only a few really essential aspects, or absolutely essential aspects of an R package. And that's your description file, your namespace, and the R directory where your R code for your functions goes. This R directory is also, as I'll show later, where you would put your documentation code, your R oxygen documentation code. That sounds like a lot of jargon, but you'll see how that works in a moment. Okay, so let's take a look at this. These three key things that we have to have in a package. So this is the most important thing, and it is this file that RStudio is using to figure out that this is a package. It sees that, and then that build tab up here is going to show up. So, oh, I just want to show you one thing. When I hit that install and restart, like it built the whole package, and now you see it loaded the package, right? It said library, my new package. It's just like any other package now. Okay, so let's look at this description file. The basic one, the really basic one, looks kind of like this. So you have your package name, what it is, it's a package, and then you'll have your title, give it your version number, who wrote it, and then who maintains it, right, little description, and then this license. Okay. So, so really nothing all that special. This lazy data one is maybe the only one that won't be really obvious what it is. So lazy data means that if you had a data folder, which we'll see later, it's going to load all that data when you do library here. So like if you had a data folder and you had something defined as a data, say, you know, sea surface temperature, it would load that, and then I could, you know, type here sea surface temperature, and that would also be loaded. So that's what lazy data means. It's just preloading your data. And whether you want to do that is kind of specific to your package. Okay, so next thing is the namespace. So back in the day, back before people started using this other package called ROxygen to write all their documentation, and I'm going to teach you how to use that later. Before people started doing that, we would write our own namespace, and this namespace is telling R what functions you would like the user to have access to once they write library new package. And when RStudio sets up your namespace, it sets it up in this kind of old style of doing it, where you're like manually creating your namespace. But nowadays, you don't really do that so much. You will use our Oxygen too. So what you're seeing here, this kind of manually editing it, this isn't what we do now, but it helps you understand like what's going on. So this is just our code, and what this code that RStudio put here is saying, it's saying export any function. This is just some code that says basically, you know, any possible combination of alphanumeric values. But typically what you do is it would look like this. So here, if I look in R, these are my functions. This is hello, so I need to look down here. So this function is called hello. And a typical entry would be like this, hello. So that would say export the function hello. Okay. But I'm just going to leave it like that, because that's just saying export everything. The other things that you'll see in here are importing. So like if your package depends on other packages, you might be importing functions here. I'll cover that in the advanced topics on week 3. Right now, we're just going to ignore that. Okay, we're not really going to play around with the namespace. Just have this here. It says export absolutely everything, which is fine. Okay, great. So covered the description, covered the namespace, and then the second thing that we have to have in a package is this R folder, and that has our functions. And here's the function that RStudio gives us. It's just this little hello function. So we can type hello, and you can see what it does. Not too much, just hello world. But you can see, yeah, it's nice. It works. And so all the things in this R folder have to be functions. They can't be scripts. They need to be functions. And in this case, how RStudio has done it, it's just put some raw comments at the top. They're not special comments. By special, I mean they're not our Oxygen documentation comments. They're just a plain hashtag here. That tells us a little bit about this package. And now I'll show you an example. I can edit this a little bit. And I will do, I'll just change this function a little. So I put my text here, print, paste, hello world. Character turn there, and then hey, come back here. My text. Okay, that should work. Save that. See something there. Okay. These, if you're not familiar with working in RStudio, those pluses there were informing me that I had a typo somewhere. Okay, I was missing a parenthesis. So now I can install and restart again. Great. Okay, and now I can do, well, if I just do hello now, it's going to complain, hey, I'm missing my text. Hello. Hello. So now you can see I have this extra hello here. I have that. It didn't quite come out the way I wanted. That's okay. I could futz with that. But anyhow, you see how, you can just edit something, install and restart, and now the function has changed. Okay. Good. Okay, so that's the basic structure. And then the basic add-ons are the man folder, and that's your directory for documentation, and then you're going to have often a data directory, and that is going to be data files that are in the binary format, which means the RData format. So that would be like if you had an object in R and you did, save that object, say, the data frame name, and you save that to a file. It's going to be saved in the RData with the RData ending, or the other ending they used is little RDA. Okay, so let's go look at this and see, because I think, yes, RStudio gives you an example. And this is the example of the documentation for this function hello. And what this allows is now when I do hello, it has that information. And this is the part where I said, yeah, it is a bit more work to write this documentation file, but that effort will really, really help you. And I don't know, if you've coded, you know how it is, like you write a function and then later you're like, what on earth do all these like input arguments mean? How did I develop it? What is the background of this? So it's super helpful. And these documentation files, they don't have to be these little things like this. So, real world example here. So this is one of my biggest package. And so like this is my help file, it's got all this information. Yeah, it took a long time to write, but this is a complicated thing. And so it's almost like a manual here. And then you have all these examples that go with it too that can run. Okay. But you can also make it really simple. Okay. And a nice thing here is you can have examples. So this is one way you can immediately test your code by having a little example. Because then when you run check here, so this just installs, make sure there's not any big problems with the code, but check is going to run the example. So let's just run that and see what happens. So run through this, and then the big thing is it's going to run through, okay, it's checking the R code for problems, great, runs through all these checks, and yes, right. So it's unhappy that I didn't define the, sorry. See, it screams at me that my documentation isn't right because this has this argument, and I needed to define that in this this code right here. So I need to add a little thing to define what my text is. Okay. So it installs all right. It's just telling me that, hey, you can't, it's not passing all the checks. So this framework here, like having the install and restart, having the check right there, that really increases the speed of work, having that right there. Okay, so a few other add-ons that you might have. You don't have to have these extra add-ons, but they're pretty common. So one is Ext Data, and that's where you'll put external data. So this, you wouldn't necessarily bundle this with your package, but it's, if you have any data in your package, it's really helpful to have the raw data there if you can. Like sometimes we can't, like sometimes it's absolutely huge, but even if it's a huge file, you you could, put the code to process that huge data file, into that Ext data, so you have a record of that. Nikolai, question, are you writing those help files directly? Absolutely not. Not anymore. That's old school, to write them directly. I did for my first big packages, I would write them directly, but nowadays everyone uses ROxygen too. And I'm going to show you how to do that, and it makes it a lot quicker. So nowadays, you don't touch that man folder. Okay. So another new thing that's, this is fairly recent, is this data raw directory. So data raw would be like, I mean, it's the raw data. My own packages that use raw data, it's all CSV files, but I guess you could have any kind of raw data there. I don't quite understand why they have this new thing called data raw when they already have Ext Data, but maybe they like the name of the folder better. Anyhow, it's a fairly new thing, but you're going to see it. Okay, so I showed you how you can modify a little function. Let's put in a brand new function. Okay, so I'm going to do this. So I'm copying that code, and I am making an R script, putting it there, and I am going to save it into the R folder. I need to put it in the R folder. Okay. I don't want it to be called that. Rename. The name of this doesn't matter. When it's doing the packaging, it's not looking at the file name. I'm changing the file name for my own benefit so that I know what this is. Okay, so this is what the packaging is looking at. It's looking at the name here. Okay, so I've got that, and on here I say, hey, add, export little forecast in the namespace. I showed you that RStudio added that sort of funny code. Where is it here? This kind of funny code. Well, that's saying export everything, so I don't really need to add that export little forecast there, so I'm not going to do that. Okay. This little function uses forecast and ggplot, so you need to make sure you have those installed. Okay, and I'll show you something that maybe looks kind of funky with this code, is that I am always specifying what package the function is coming from. So I said it's using something in forecast and ggplot too. And notice I've specified here that AutoArima is coming from the forecast package and AutoPlot is coming from ggplot2. I want to say you don't have to do that, but that's not quite true. You cannot pass the R checks without doing that. You don't have to pass R checks for your package to work fine. It's just that your package is not going to be as robust. If you were to submit it to something like CRAN, it will not pass unless it passes all the checks. Because I create packages that go onto CRAN, I always put this into my functions. Just as a matter of course, I'm not going to be using, just writing like AutoArima if I'm writing a package. I might do that like if I'm teaching or something, or I'm writing a script, but if I'm in sort of package brain, I am always specifying what package my functions come from. Okay. So there we go. So you see, that's all I did. I added that my little forecast here. And now let's build it. Great. And now we can use our little function. Copy that. I paste that code in. So there we go. So now I have a little forecast. So I just pass it in some data, say how long I want the forecast to be, and there it is, right there. Okay, so that's it. I could also add some data to my little package. So let's do that. So this World Wide Web usage, this is something that's just bundled with base R. It's not something I created. It's just one of the data sets. And I'm going to square that data frame. Let's see, I'll show you what it looks like. Okay, so it's just a time series. Okay, we could do, plot. There we go. That's what it looks like. But what I'm going to do is I am going to create the data folder. So I need to create that data. That's where my data is going to be. And then I do this. So I create the new data. I give it a name. So I'm going to square this data usage. I'm going to give it the name WW2. And then I'm going to save WW2 into data. So now, there we go. There's that data. So remember I told you in the description file we have lazy data is true. So what that means is WW2 is going to be loaded whenever I install the package. So now, boom, I click the install and restart. And now if I do WW2, you see, it exists. So I created a data object that is loaded whenever I install my package. So whenever I load my package, when I run library my package, this data is going to be loaded. Okay. Good. Okay. Okay. So I'm going to quickly put this up on our organization for the workshop, just so you can see how it's done. So I clicked that little thing that said when I created the package. Remember, I clicked the little checkbox to make the folder a Git repository. So I'm going to follow these instructions. But if you hadn't done that, you just follow these instructions up here. Jason, so yeah, it will be auto-loaded, yes, if you do lazy data : true, then it will be auto-loaded. That's really important to know when you are creating data packages. So like if I'm creating a data package, I will often have that false. And when I get to the second half and in 4 minutes, I'll start on data packaging. I'll talk about why I would set lazy loading equal to false. If lazy loading is equal to false, what that means is to load the data, you have to say data, then the name of your data. Yeah. So if I had lazy data false, I'd have to say data WW2. The fingered things, it means I'm putting WW2 in quotes. Andy, do I use the this package? Yes, I do use the use this package, but I'm not covering that in the workshop. In the first two workshops, I'll talk about that in the advanced one. Just trying to tone down the content overload. Okay. So let's go ahead and get this up onto GitHub so I can share it with people. So let's go here. Okay, so I'm here, and then I'm going to go add. That's up there. Add local repository in file. So I need to find it. So I put it in my desktop. There it is. Hey, chat windows covering it. Okay, there we go. Okay, so I added that. Nice. Okay, and now you see it says publish repository. I'm going to do it. Okay, no, private, you wouldn't see it. And then I have multiple organizations. So I can put it here, and now I publish it. Great. Cannot publish an unborn head. Oh, okay, fine. It's saying, hey, you haven't actually committed anything. Okay, fine. First commit. That's what it wants me to do. So now I have done my first commit. Now I can publish it. Okay, excellent. So now if we were to go on GitHub, we will see that there's a new repository called My New Package. And that's it. That's as easy as it is to get up there. Now people can see the code, but they can also install the code from GitHub. And it's in the DevTools. I think there's also a package now called Remotes that people are using. Does the same thing. Install from GitHub. So it's really easy to share packages that way. I have a section here on installing from GitHub headaches. This is mainly for those of you on Windows machines. Look at that if you are running into headaches. I'll give you lots of tips for dealing with that. Okay, so with that, little whirlwind introduction to a package in R. I'm going to move on to a data package and show you some examples of how you can use, how you can create and use data packages in your work. Before I move on to the data packages, I will say that like what I've shown you right now is really basic, but it'll take you really far. Like just doing the things that I just showed you, putting all your functions in, making it functions and putting it into R, into the R folder like that. And then doing the next thing next week when I talk about documentation, adding this little code at the top of those functions to say what it does. Just do that. That's it. That will it will make you so much more robust as a programmer. Just doing that much. Okay, so let's move on. Let's talk about data packages. Okay, so as I mentioned, you can put data into any package in R, any R package. So what's like a data package? So there's nothing special about a data package. It's actually really exactly the same. The structure is exactly the same. You don't need to learn anything new. But a data package means generally that the package is devoted just to data. So it's like a choice of the designer. It may have a few little functions to use the data, but it's not like not like a whole lot of complicated functions for doing analysis and such. And in my work, I will tend to have a separate package for my data, and then another package for my analysis code, the thing that's going to write the report or write the paper, do the analyses for the, whatever I'm working on. And that other package is going to, it's going to load my data package. So I keep my data separate. And the reason I do that is it's easier just to share the data, and I may have multiple projects that are using the same data set, and I definitely don't want to be copying my data across multiple repositories. That is a recipe for disaster. I want to have one data package and then my things referencing it. Is there a size limit on data files? Yes, there is. It's a GitHub limit. It's not an R package limit. It's a GitHub limit. I personally haven't run into it, even working with remote sensing data. I don't know. I guess my data things maybe 50 megabytes kind of data things. So I guess if you're working with terabyte data, then yeah, you need to be thinking about that. And so you'd need to Google how people are dealing with big data and R packages. There are approaches for that. Yeah, I think for GitHub, I ran into something like, but that's the 100 megabyte, I think that's per file. That's not like the total thing, it's just per file. So if you break it up into smaller than 100 megabyte files, you're okay. All right, so let's launch into a data package and kind of show you an example. So I'm going to stick with my new package, and I'm going to add some data to that. And I'm now going to switch into using the ROxygen2 workflow for my documentation. And this is what you should use too. You should learn ROxygen2. You should not be writing your documentation, those RD files, manually. So first thing that you need to do is to get it set up is you need to install the ROxygen2 package. So just go into packages, install ROxygen2. You'll see it right there. Okay, I'm not going to because I have it set up. Okay, the next step is here I'm in a package. You see that I've got the build thing there. I need to go into Tools, Project Options, Build Tools, Generate Documentation with ROxygen. If you don't see this little checkbox here, then make sure that you've installed ROxygen2. It's only going to show you this if you have the ROxygen2 package. So I want to make sure I click that. So I click that, and then the configure thing jumped up for me. And if you have vignettes, you click that. We're not going to have that, so I'm not going to click that. But what I do want to do is every time I install and restart, I want it to build the documentation. So I always click that because in my workflow, I like when I rebuild the package, I want the documentation rebuilt too. So, okay. Okay, that's good. All right, so now I've gotten that, and now I am going to, I'm not quite going to do it like this. I think what I'm going to do is I'm going to add, I'm going to show you how to document WW2. Because I've already created a data set, I don't have to go. So this step right here shows you how to create a data set and how to save that that as like mydata.rdata, but we've already seen that with WW2 that I just created. So let's create the documentation for WW2. So right now I'm showing you the part of data documentation that you kind of never guess unless someone told you or you read the book, because to me it's pretty non-intuitive. So I've got this data here, you see, WW2, and I need to create in R, I need to create a new file. It's R script, no, it's weird. And now I put this code, this is our ROxygen code. Don't worry too much about it. It's pretty readable. We'll learn more about how to do this next week. Basically, it's got a title, and then it's got a description. These @ signs are really important. The hashtag with the little mark and the space, that's all important. Data squared. You tell it a little bit about the data. Yep. Doc type data, the name of it. It is not my data, it's WW2. This part is important, having the right name. Usage, tells you how to use it. I don't think this usage line is 100% important, but we'll put it in there. There. And format, you tell it what the format is. And the format of this is a TS object. well, the time series object. There we go. Okay, great. And now I want to save this as, okay, so remember, it doesn't really matter what I call this. I could just call this, data documentation. And you got to come up with the naming that's going to help you personally and work for you. How I personally do it is I have a single file for each data object that's going to appear in that data folder. That's how I do it. Other people, they will have one folder, one file for all their data objects, and then they just be repeating this code over and over. So they, do a few carriage returns, and then they'll have this same code for their next data set. I personally never find my data if I do that. So I do it like this. I put .data there. It's going to be .r. I do it like that, and that way I always find data. Or I might do, I could do like a data. Maybe it'd be better to do data, something like that. So the thing is that I want it to know that it's a data documentation file. So there we go. Okay. So let's go back here, and I want to get rid of this because this is not our oxygen code, and I don't want this to scream at me. Okay. So let's do install and restart. Okay. First time using, okay, my package, yep, updating, fine, good. So it says it wrote the RD file for that, yay. The existing namespace file was not generated by ROxygen2 and will not be overwritten, yay, thank you. Okay, I didn't want it to overwrite it today. Okay, so now I have that ww2 data, and now I should be able to do this. Yay! And now my data showed up and my information about it. And I find this feature so incredibly useful. Even if I created the data package, I am constantly doing, question mark my data name to remind me, oh yeah, where'd that come from? Oh wait, what's going on with that? And you can put anything you want in that documentation. So, it's just personal to you. You have whatever description you want, whatever information. There's a bunch of other standard tags, references, citations. Yeah. But the basic form is just like what you see here, just like that. Okay. Yes, thank you, Daniel, for that. Lots of information on writing documentations. Oh, that's vignettes. Yes, thanks. Yeah, I'll talk about vignettes another day. So there's lots of information about writing these ROxygen tags, and I have that information down here. So if you sort of see that, you can, there's a nice section there, and then the R packages has this big thing on our oxygen documentation. But like I said, I'm going to cover that more next week when I'll talk about package down, making a web page, and I'll also go a lot more into this R oxygen too. But you see, just by doing a little bit of tweaking there, I was able to write that RD file using ROxygen2, and then I never have to touch this. So this, you can see, and it warns me, hey, don't edit this. ROxygen2 created this, which is so nice. You don't have to remember all these tags. So now when I'm working on a package, I'm never touching the man folder. All my documentation is going to be at the top. So here's a function. Normally I would have a bit above this, which is the ROxygen2 code that's going to write the documentation. Okay, so So a little more comments on creating your data documentation. I'm going to show you another way that you could write that documentation. And if you look in the book, in the R packages book, in the section on data documentation, they are going to show this other way. So let's see. See if I, okay. See if this works. I think this is how it is. Okay. So let's try that. Talk about it. Yeah. Writing. Okay, good. Okay. So now I'll try it again. Oops. There we go. So it still came up. Okay. So let's talk about the changes that they've made now. And I think, you know, they felt that it was just, you know, a little redundant, some of the information that was in their previous documentation about documenting data sets. So they, let's see if I can go back here. Yeah. So they got rid of saying doc type, and they got rid of the name, and got rid of this null. So in an R oxygen, it has to have something at the bottom. And so normally it would be like your function code, but when you have data, it's not a function, so you have to put something there, so you have to put a null there. So I think they felt like, well, that's just kind of confusing. If you, you know, if you have data, you can just, you know, put the data name there, and then our oxygen is smart. It can figure out that it's a data, so we don't need that. And you got the name here, so you don't need that. So the problem with that, I personally find, and the reason I don't do that, is that only works if you are exporting your data. So if you have lazy data equals true. And I often don't have lazy data equals true. And the reason is the nature of the kind of data packages that I do. And I'm going to show you an example of a real data package. So this is VR data. Okay, come back here. Okay. So this is VR data. This is work in progress. This is spawner and fraction wild data that's being used for viability reports that we prepare at the center. This is all data from the 2015 viability report. And you can see here, you know, has all the data here. And then it has data reports, you know, information on the data. Okay, so that's all cool. So nice. But the structure of this is, this whole thing, this whole website here is written with the standardized code. So I don't go and write these reports. I just have a little bit of code that writes this standardized markdown file that creates this. They're all identical, right? The only thing that's different is the data that were sucked in. So if you look at the repository for this, so let's, okay, how do I show this? Yeah, so this part is really not obvious about the data thing. Okay, so, okay, I'm going to show you the data. This is the R oxygen for this data. Oh, okay, I'm going to back up a little bit, show you the structure here. So first, there's this data raw. Okay, so this is the raw data. And the way I have mine set up, it's a little bit unique in that I have kind of the unique our oxygen code at the top of my CSV files. That's not like a standard R package thing. It's just the way I wrote it because we need to keep our metadata with our raw data. And my code reads this and adds some other stuff to it and creates these data documentation files. So I didn't create these like manually. It just sort of sucks in the header at the top of the CSV file, puts that here, looks at what the column names are, adds the description of that, puts the name here, it's a doc type table, it writes some example code. So my function is just doing that. And then my function also creates these vignettes, and this is kind of the part where lazy data equals true would be a major problem. So so my code is writing this vignette, which when you click on the web page, you click on the documents. This is what is the code that's generating those nice little figures. And so this code, when I load this data, the thing that's being loaded is a data object called out. Okay, kind of boring name, but that's what it is. And every single data object has that object out. That way, I can just write this same code to make output from any of my data files. Okay, my data files are really exactly the same in structure, so it would be a nightmare if I had to call each data, Columbia River ESU, and then the next code I had to do Hood Canal ESU, and imagine if I have like these long scripts that are doing exactly the same. I don't want to be changing the name of my data each time. So I name the data, when you load the data, it's always the same name. So it's true, I can only load one at a time. But in the nature of this particular data package, I only would need to load them one at a time. I'd load one, I'd do all the scripts, go to the next one, I'd do all the scripts. So if you did lazy data equals true, it would say, hey, no, you can't do that. You can't have data objects with the same name. And you may look at them and say, hey, Eli, they're not the same name. Look at that data. Look, they're all different. No, they're not different. That's just the file name. That's not the name of the data. The R package doesn't care about what the file name is. It cares that when I click this, it's loading something. What is it loading? It's loading a data frame called out, and that's what it cares about. What is that thing that's being loaded? Yeah, so that's why I often don't use lazy data equals true, because a lot of times we'll have data objects that have the same name for various reasons. Okay, great. Okay, we are at 11:01, and I'll finish up and show you the it's kind of the workflow for a new data package, and it's very similar to the workflow for a regular package. You're going to create the new R package in RStudio using new project. Daniel made a comment in the chat, I think it was Daniel, about the use this package. If you do a lot of R packaging, I would definitely Google that. You might find it useful. I never used it for a long time, and I still don't use it, but I mean, I do use it for some things. I don't use it for making packages. So it's put it in the chat. It's called the use this package. Okay, so you create that. You install ROxygen 2 if you don't have it. You create the data file, and then you start saving your R data files to the data folder. be a little careful if those R data files have multiple data objects in them. So each of those things in there, so let's say you could do something like this. I could do, save A, B, C, file equals abc.rdata. So I'm putting that in my data, okay? So I can do something like that, but be careful, that's fine, but these are 3 different data objects, and you need to document all 3 of those. Okay. So think about a little bit about your workflow if you really want to bundle things together like that. And there's no right or wrong answer there. It kind of depends on what you want to have. I guess kind of what makes sense to you in your work. How you won't get yourself lost in the future. Okay, so you add those to the data file, and then you're going to add your R files that document your data. And then decide whether you want lazy data equal true, which means you just load the package and you have access to the data, or if you want to say lazy data equals false, and then the user will have to run the code data, parentheses, name of your data to load the data. So you just decide which one of those you want to do. And yeah, that's about it. And then make sure that you've checked that it's building using our Oxygen, and then install and restart. That is it. Okay, great. It is 11:04. I am going to stop with the lecture part and open it up for questions for, on any topic, on this topic, or any other topic. And while you guys are thinking about that, Amy, can you expand a little bit on the comment about one thing to explore for problems like this is using a sign?
Can you hear me, Eli?
I can, yeah.
Okay, yeah, no, it's just a base R function. So you could, load your data that's called out, and then you could assign it a new name. It's just a workaround. It's just another workaround that I use sometimes.
Yeah. There's a number of workarounds, different ways. And I did think for that VR data package that I'm developing, I was hesitating at giving everything data the same name. And then I finally decided, well, for this purpose, it's fine. But yeah, definitely using a sign, I could get around that. Okay, so questions. Elizabeth, can your data documentation get the version info from GitHub? Yes, you can. And I cannot tell you how to do that off the top of my head, even though I have done it. But what I will show you is so Google that, people do that. But at our command line, once you have it installed, it's pretty easy. Just do my new package. You have to have the right name. Yeah, there you go. So you can do that at the command line. And I should have a little thing here, using our new package. Code here. Using. Did I not put it here? I'll put it here. Okay, so Okay, yeah, here it is. Yeah, so this shows an example of kind of how you you might use the package version feature. So let's see that. So I'm just going to make do file, new file, R Markdown, and I'm going to do create an empty document. There we go. I'm going to paste this code in. And if you needed to install from GitHub, you could run this. That assumes there was a release. There isn't a release yet. So you would install that, but we're not going to do that. Okay. So let's save that. We'll just call that test. Okay. And now we knit this. What are you complaining about? Are you happier? No, still not happy. What are you unhappy about? What are you unhappy about? Oh, come on. Table.
I think it's the parenthesis you closed with is different than the one you open with, or not parenthesis, quotation mark style.
Thank you.
Yep.
I could not see that. Okay. Okay. Object my data not found. Okay, fine. Okay, try that again. See what happens. Okay, so this is kind of a silly little example here, but it just shows how to put a caption on with the version number of the data. So that's something that I will add to my data, either captions or the footer, and it's a really easy way to make sure that the data in your reports is using the latest version of the data. Okay, so but that question about the version on the release for GitHub reminds me that I didn't show you how to make a release. And yes, William, yeah, you have to make sure that you're updating your version number. That's really important. So so let's do the second update, and we're just going to make a release here. Okay, no, don't do that. Whatever you're doing, don't do it. Okay. Okay, so let's go over to our workflow workshop. Okay, so we're here. All right, so to create a release in our GitHub, you go to your repo and then you just click releases. So you create a new release. All that was happening when you're doing this is that you're giving a name to a place and time. So you can call that tag anything you want. There's just some kind of standard things that people would use, which is like here, I do the version. I'm at 1.0. That's a common thing, but as I said, you can call it whatever you want. If I'm writing a paper and I have it on a repo, I do releases, and my releases would be something like first submission, second revision, you know, those kind of things. But if I'm writing a data package or a code package, it's going to be something like this. And then, again, the release title, you can call it whatever you want. But I try to do something fairly standard. Data package. You can describe it if you want, whatever you want to write. Okay, and then publish it. Great. So now it's got the source code here. And the nice thing about that is that you can direct people to download specific releases rather than going and installing the package from your master here. Because it may be that you're working here and like this is the development stuff and you don't want people using that, you would like them to use this. And all you do is, with this code right here, if you add asterisk release, that is going to install the latest release. I don't know off the top of my head how you specify a specific release, but that's easy to find with Google. It's just you. I think you just put the tag name on the end of this. So that's really easy. And a nice feature that I like about the releases in GitHub is you can edit them. Oh, it's so nice. You just go there, edit the title, add more information. I'm often going back and adding more details. So, and then you update it, which I didn't. Okay. All right. So, any other questions on anything? Okay, while we're thinking of questions, I want to point you to some really great resources from the Fisheries Integrated Toolbox. So lots of great info. Really encourage you to read that. So there's this cool blog here. So go here, and then if you scroll on this side, all this good information. So if you're working in a team, you don't want to like kind of make up everything about, how to do code review. I mean, you have to customize it to your own team, obviously, but a lot of people have thought about that, and people who are working in the same area as you have put a lot of thought into it. So, read what they've come up with, and that'll really help you. I think this one, this is kind of it's a checkbox. Oh, I have to find the checkbox. I'm missing the checkbox. Darn it. Okay, I don't have the link. There's this nifty whole checkbox things for when you're developing an R package, just to help you go through to make sure you don't miss anything. I'll add that to this, and I'll put it in our chat for the over here. If you're not here, this is where I'm posting like little discussion things. When Teams, our workflow, you may be getting emails about this if you've set it up to get notifications. So I'll put the link on Fit's little checkbox thing there. Oh, maybe it's here. Yeah, here it is. Yeah, okay. I do have it there already. So this just, kind of walks you through. If you develop package, I am sure you're, already doing these steps, but even though I develop packages all the time, I found this checkbox page helpful, reminding me, just kind of go through it and, don't forget anything. And yeah, great. Okay, so next week, we're going to go into how to write that documentation. I'm going to go into that a lot more. I just scratched the surface today. Then I'm going to show you how to use package down to make package websites that are branded for NOAA. What does that mean, branded for NOAA? Well, let's take a look. So here is one that is branded for them. Oh, I don't have the disclaimer there. I haven't completely branded it, but it's got the colors, the NOAA colors. It has this standard format here, and there is a standard disclaimer and a NOAA footer that should have been on here, but I guess I missed it. But they have that and all the logos and everything, so that's a really great resource, and I'm going to show you how to use that on next week. Okay, last chance. Any other questions? You throw it into the chat or just unmute yourself. Okay, I think we're good then. And feel free to email me if you run into trouble. Okay, I will see you all next week then.